gathering information for all mankind about the earth and the sky and the oceans. They study the ice.
What's that? Or here, I mean, there's almost like, you know, there's stuff here. So maybe, you know, I don't know. Maybe there's a piece of a little, you know, not a pressure ridge, but a raft or something. So you might want to go around and see whether you can find a spot that's completely smooth and level. Because if you drill in here, you might find that there's deformed ice all the way down to half of the ice thickness. So I would say, you know, it's tough to tell, but one group can just pick up snow. You know, some of this stuff may be snow drifts, but some of it, certainly here, might have the core of you know, you can see, I mean, there's already more solid ice here. You cut a square like so, you lift that out, right? And now you have a nice wall cross-section of the snow, and as you clear this away, you can already tell, well, okay, this here actually seems to be fairly square, right, and fairly level. You do the same thing again here, and I admit, I mean, this is not a great shovel actually for what you're trying to do here, but do the same thing here. I sort of have a feeling that this area here might be quite nice. So why don't you see whether you can get yourself set up there.
16. 15 and a half. 14 and a half.
So what do you need for drilling an ice core? You need your core barrel. This one here is fiberglass and has a top coupling here that you simply push in once it's aligned, and then we're using this safety disc here if we're drilling with an electric drill, because the top here might actually come sliding out of the drill when we yank it up, and then this disc here is going to prevent the whole assembly from dropping into the hole. And then we're going to have to connect our actual electric drill, which is going to fit on top of this connector here. And yeah, if you can hold that, that's great, thanks. And then we'll just have to tighten this very well, so you want to be sure that you tighten this on all three sides. All right, there we are. So now you're basically ready to go and actually start drilling the core. If you operate such an electric drill with an ice core, you really have to watch out for a few safety issues. The first one, of course, is you always want to look where's your plug, right? You don't want to have that lying around in water. Now, the nice thing is, what's that yellow and black box? GFI, and that is a
ground frequency interrupter.
Ground fault.
Ground fault interrupter.
So if you accidentally, if you drop this into a pool of water that's conducting into the seawater, it's as if you were on ground and you're draining large currents in there. This thing is automatically going to shut off. So you can't really electrocute yourself with that on there. So that's one key concern. Always make sure that your plugs are clean, free of water or snow. The other issue, of course, is this is a very powerful drill, and so you want to be very careful that you always hold the drill. I mean, this thing is almost like a shotgun, right? You never put your finger on the trigger unless you're sure that you want to drill. And when you start drilling, you want to make sure that you have the drill very firmly and secure in both of your hands. One of the common mistakes is that people, they hold this, you know, and then they're looking at this here and they're coming up and they're hitting this thing accidentally while they're loosely holding the drill. The drill starts to spin and, you know, you can sprain or even break your wrist. I personally prefer not even holding any part of the drill other than the electric drill with both hands, just one person when you get going. And then once you've drilled a bit so that the drill has sort of settled or eased into its little hole, you want to make sure that the drill is exactly vertical, right? So you're going to have to look at that from different directions, and then make sure that as you continue drilling, once it's found that perpendicular, you know, nicely aligned hole, it's just going to keep on going, but you don't want it at an angle. But once it keeps on going, then really just one person can drill on their own, and occasionally you have to lift up the drill to remove the shavings and the drill cuttings from the hole, and then somebody else might use their boots, or even if you have the rubber gloves, you can move that out of the way as long as you don't get snagged. And then you just keep on going until, you know, you're 3/4 or maybe 5/6 or so the way through with the core barrel, and then you stop and take out the core. Okay, that's better. So this here, notice how, you know, just from the drilling there's a bit of slush in here. That's actually not ice, so we can, you know, we can just take that out. Whereas this here is solid ice. Goes in here. So this is the core in its entirety, and it's 1 meter and 43 long. So that was minus 1.5 at 40. Next one is at 50 centimeters. We're measuring temperature in the ice now by drilling a hole, inserting a thermometer. Minus 2.0 at 70. Minus 2.2 at 80, and the last one is at 90. And normally what we have on top of the ice is a sleeve with holes in it that we drill through to shade and insulate the ice core. Today we're not using that, and so we're putting the box in here so that we're shading the thermometer so that the thermometer doesn't heat up by the sun. So now I'm just pre-marking the core at 5 centimeter intervals. Okay. Okay, so it looks like we have enough bags here, and there's also some markers there, so you can mark those either out on the ice or here. And then there's one other thing we're going to measure on the ice, right? Well, yeah, first of all with the core, the core pieces, yeah, the mass of the pieces. So We've got digital balances here too. Actually, there's a caliper here for measuring the exact dimensions of the core sections. You might want to clean off the slush, right? If you measure density, then that slush. And yeah, actually, the polarizing sheet you can put aside for now. We'll use those later. They're just easily scratched.
Probably just need one two or three.
All right, yeah, you can disconnect that. Oh, that's okay. Thanks, Dan.
Okay.
This is kind of more play court,
Oh,
to be quite
okay.
honest, but here, if you guys can take that, and then there's a piece in there, but I'm just going to grab this real quick here.
Do you want to keep going down?
No. I think this is good enough. Yeah. Yeah.
Does it get close it?
So when you take a, okay, yeah, right.
That mine. Okay, so
Just
just
see
get the
them
core
pulled out, the air is
back in there.
clearly colder,
Yeah.
so it's just warming up.
Where's
So-
the extensions?
Okay, that's okay. This is another. This is 10.
This is 10. Okay, so
But it's getting colder now, right?
Is it?
I mean, yeah.
right.
So that clearly can't be, what's the air temperature
No,
here?
I think I had it backwards because of the.
On one end 109, on the other 112. About so. Oh, nice.
Oh, you can trace a really nice front on in this one. No,
Oh yeah, I do.
Can I hold that up now?
Oh yeah, that's neat.
Oh, that's what it is. It's not a brine drainage channel
Yeah.
at all.
Oh really?
That's where the
Yeah.
temperature measurement was. Oh, okay. Well, I'm glad we figured that out.
8.95.
Okay.
.79 for the mass.
There, Link. You might want to clean off the slush, right? If you measure density,
5.
then that
9.3.
slush.